Hi, good day to everyone. We are from Engineering Statistics Section 21 and our project is Pure Lajak Kuruih and our members are PRITOM, me and NGIEN. Okay, so why are we doing this project? We are doing this project due to there are some problems encountered during the manufacturing of the table. For example, the problem tested during manufacturing the table are inconsistent of table harness and the rack. Okay, so that we need to ensure the table uniformity at every batch products. Okay. So for our group, we are in charge for batch N, which have 200 samples were affected for morning, evening, and night shift. Okay. Based on the 200 sample affected, we can come up with the data analysis so that it is easier for the top management to view the data. Okay. So we can come up with 3 different types of data analysis, which are tabular form, numerical form, and graphical form. And this is the first form, the numerical form. Okay. So this is the table 1. So the table 1 shows the sum of the wet and relative density and tensile strength for morning shift, evening, and night. After that, they sum up all the morning, evening, and night to get the grain total. Okay. As for table 2 is doing for the mean of wet, mean of relative density, and mean of tensile strength. Okay. That's on the morning, evening, and night shift. Okay. So for the third table, which is the calculation of mean, median, mode variance, standard deviation, maximum, minimum, range, and count for the wet, relative density, and tensile strength. Okay. So the second form is tabular form. Table 4 is you can see the range of the relative density and their frequency. As for table 5, which is the range for wet, and table 6 is for the tensile strength. Okay, so now we are going to discuss the graphical form, and this is for the mean. Okay, so graph 1 shows the mean of a wet in milligram. Okay, as you can see from the graph, the morning have 346.94 mg, as for evening have 351.81 mg, and night have 348.35 mg. Okay, so for graph 2, it shows the mean of relative density. Okay, morning 88.05, evening 88.08, night 87.94. Okay. So for the third graph, it shows the mean of tensile strength in MPa. Okay, so morning 7.17, evening 7.14, and night 7.13. Okay, so now is the graphical form for frequency. Okay, so for graph 4, it shows the frequency of wet, and graph 5 it shows the frequency of relative density, whereas graph 6 shows the frequency of tensile strength. And then for the next part is the question B. Okay, and I will pass to PRITOM.
My name is PRITOM. Now I will talk about question B. The question B is determine the tablet meet every standard frequency table goodness of fit test. The hypothesis statement is A0, the weight normal distribution x 350 14 square. S1, the weight does not follow 350 14 square. The significance level 0.05%. In this slide, we calculated the probability by using normal distribution formula. So the normal distribution formula is x minus mu divided by variance. After that, we will move on the goodness of fit test. There have lot of range. So you have already find out the probability in the previous slide. After that, we will find out EI and x square. X square equal OY minus EI whole square divided by EI. This table shows of some data are same. So after that, the table shows if we will combine this data, this look like that. Test statistic. Since EI greater than or equal 5, where I equal 1, 2, 3, 4, 5, and 6, then K equals 6. Now P equals 6 minus 1, where P equals 0. X2 test equal 4.539. So our decision rule is x2 0.05 or 5 equal 11.0705. Rejects A0 if x squared test greater than x squared 0.05 or 7. In conclusion, since x squared test equal 4.539 less than x squared 0.05 or 5 equal 11.0705, thus fail to reject A0. We can conclude that the weight of a standard table produced by manufacturers meet the requirement given by the Food Drug Administration, which follow normal distribution of 350 mg and standard deviation 14 mg. That's all. So our next part will continue our member Rion.
My name is Yuri, and I'm going to continue the presentation with the question C. So question C is about comment on whether there is any significant difference between tabular split from the differentiate. Since we are going to perform the one-way Anova method, so the data has been summarized into a table which consists of 3 groups, which is morning shift, evening shift, and also the night shift. So for the new hypothesis, we are going to make it new morning equals to new evening equals to new night. And also for the alternative hypothesis, is equal to at least one mean is difference. And for the significant level, we are going to put it at 5%. So the one-way Anova method is performed using the Microsoft Excel, and this table shows the result from the Microsoft Excel. And we have two decision rules, which is one, we will reject the new hypothesis if the F calculated value is greater than F physical value. And also, we will reject new hypothesis if our P value is smaller than the significant level value. So in conclusion, since our F calculated value is 2.333544, which is smaller than the F critical value, which is 3.041753, and also for the P value is equal to 0.099626, which is greater than the significant level, which is 5%. So we are unable to reject the new hypothesis and conclude that there is no difference in the mean tablet weight of 3 different shift periods. Thank you, that's all from me.
Okay, so for question B, we need to predict the tensile strength for tablets for relative density value of 68%, 74.3%, and 80.1%. And after that, we need to comment on the validity of the model. Okay, so for the method we use for question B is simple linear regression. And then here are the 3 tables which we can get from the Excel. And the hypothesis here we use is H0 beta equal to 0, which means no linearity, and then H1 beta not equal to 0, which means linearity exists, and the alpha we use here is 0.05. Okay, so for the decision rule, if significant F is less than alpha, then we need to reject H0, and if P value is less than alpha, we also need to reject H0. Okay, so based on here, we can see the significant F at the table, which is 2.45946 times 10 power of negative 57, and for the P value is 2.5 times 10 power of negative 57. So both are less than 0.05, which means we reject H0 and conclude that there exists linear relationship between relative density and tensile strength at a significant level of 0.05. So this one is the graph for the simple linear regression after we use the Excel, and then we can plot it. Okay, and since we have know the data of alpha and beta, so we just substitute into the y equal to a plus bx, and then we can get the straight line equation y equal to 0.3536 plus 0.0771x. Okay, so now we come to the estimation part. Okay, this is the table for the estimation calculation. As you can see, we have relative density for CCA 74.3, 80.1. After that, we just sub it into the x value in the straight line equation, and then we can get the y value as our tensile strength. Okay, so in the result here is at 68% relative density, tensile strength is 5.5964 MPa, and then 74.3 is 6.0821 MPa, and 80.1 is 6.5293 MPa. Okay, so for the comment, okay, the first comment is the correlation coefficient r equal to 0.8511 and coefficient of determination equal to r squared equal to 0.7244. And for the second comment is relative density and tensile strength are in strong positive linear relation due to the r is in between of 0.7 and 0.89. Okay, so the third comment is if r squared equal to 0.7244, which means that 72.44% of the original uncertainty in the value of the tensile strength can be explained by straight line equation, and then thus the SLR model relative density is considered accurate. Okay, so that's the whole conclusion for this project. Is based on good enough of fit test, the weight of standard table produced by manufacturer meet the requirement of the food and drug administration FDA, okay, which are normally distributed with 350 mg with standard deviation of 40 mg. And the second is based on the Anova test, which is from the question C. Okay, the results show that there are no significant difference between tablet weights from the different sheets. And for the third conclusion is from simple linear regression, we conclude that there are existing linear relationships between relative density and tensile strength at alpha equal to 0.05, where correlation coefficient R show us that the relative density and tensile strength are in strong positive linear relationship, and coefficient of determination R squared tell us that the regression model is adequate. Okay, so that's all from my group. Thank you.